So I recently saw a video on this integral of x to the power dx minus 1. So let's discuss this idea and let's see what is the reality behind this idea. But for that, please do like, share, subscribe and please support this video. Now let's start. So first of all, let's understand the idea behind this integral in the video. So what they did was they stated that we can write this as x to the power dx minus 1 divided by dx times dx. Okay. And then what they claimed that x to the power dx minus 1 divided by dx can be written as limit as h tends towards 0, x to the power h minus 1 divided by h. And then you can use L'Hopital rule and you can say that this is equal to ln x, right? Okay. So we can say that this integral is same as saying ln x dx. Okay. Now my opinion is that this integral does not make any sense. It is invalid integral. So this claim is false according to me. So let's discuss that. Because what is the idea behind integral? Well, suppose this is a curve like this. So it is going from A to B, right? Okay. So the area under this curve y is equal to fx is given as integral a to b fx dx. Or if you go along vertical axis, then it can be given as c to d function y at y dy. So this is equal to area and this is equal to area. So the key role of integral is to find the area under a curve, right? So when we are saying integral of x to the power dx minus 1, we don't know with respect to what quantity are we integrating, because it is ambiguous over here, because dx is in the exponent, not in multiplication of the function, because area is length times width, right? And the second claim which is given by me is that when we are saying x to the power dx minus 1 divided by dx multiplied by dx, and then we are setting this as a function, that function is x to the power dx minus 1 divided by dx, and then we are setting it equal to limit as h tends towards 0 x to the power h minus 1 divided by h. Well, dx has two meanings. It can be used as symbol over here, or it can be seen as an infinitesimal value. Okay, but the claim over here is that we can write dx as h. Okay, I can agree to it, but the claim over here is that dx over here and dx over here is different. I don't agree to this, because if you are saying that we can set dx as h, then is equivalent to saying as h tending towards 0, then I can say over here also that limit as h tends towards 0 x to the power h minus 1 is equal to 0. I can say it like this also, so it becomes integral of 0. How? Because x to the power dx is minus 1 is equal to, is same as saying limit as h tends towards 0 x to the power h minus 1, which is equal to 0. So again, integral 0 does not make any sense. Now many people claim over here is that instead of saying like this, we can say it like this also. We can say it like this, that e to the power, we can say x to the power dx as e to the power ln x to the power dx. Okay, before that I need to tell you one thing. If you are seeing dx as a symbol, right, then it is similar to saying x to the power apple. Integral of x to the power apple and dx we can put. Does it make any sense? No. Why? Because apple is symbol, not a number. When we say x to the power n dx is equal to x to the power n plus 1 divided by n plus 1 plus some arbitrary constant, when we get this as the result, then this makes sense, because it is the area under that curve. Which curve? Y is equal to fx is equal to x to the power n, right? Okay. Now coming back to this. So many people claim that we can write its Taylor form. It is 1 plus ln x dx We can, because we can write it like this also, e to the power dx ln x, because if we see dx as an infinitesimal value. Okay, because we know that dx is very small value, so we know that e to the power some epsilon naught, when epsilon naught is very small value, it can be approximated as 1 plus epsilon naught. Okay, so we can write it like this, and when we subtract this we get this integral ln x dx. Okay, so far so good. Okay, so we got this integral ln x dx. Okay, so we know how to solve this, we can easily solve it, I don't need to tell you. Okay, but what's the problem over here? Because from here we ended up here, so we got a valid integral. But the problem is that this function has no graph, and since it has no graph, it has no area under any graph, and hence it has no integral possible. So now I know many people claim that if fx is equal to x to the power x, and if I say integral x to the power x dx, we all know that it has no standard integral. So does it make an invalid integral? Of course no, because it has still a graph. We all know its graph, right? You can plot it also on Desmos or any other graphing tool you can use. So it has a graph, so of course it has some area under, so it has some area, right? But when we are dealing with this function, it has no area because it has no possible curve, right? So how can we go from a function which has no graph to a curve to a function which has a graph? How is it possible? Because we all know that ln x graph looks like this, right? So how can we go from no graph to a graph? So this is the first claim which I am claiming over here. So it is not possible to go from here to here, because it has a graph, it does not have any graph. Okay, and the second thing which I am claiming, that if you are treating dx over here as h, then why can't I treat it like this over here only, and I can say that this is equal to 0. So we are dealing with integral 0, which itself does not make any sense. Why are you treating this dx different and this dx different? That is my claim. If you're treating this dx as h, treat this also as h, then you will get limit as h tends to 0, x to the power h minus 1 divided by h times h, which is equal to 0. So this is my claim. And the third claim which I'm making, that if you're saying it like this, 1 plus epsilon naught, so you are saying 1 plus ln x. What if I change the integral from x to the power dx minus 1 to integral x to the power dx? So it will become 1 plus ln x dx, so which is equal to integral 1 plus integral ln x dx, which again does not make any sense, because we all know we can integrate this stuff, but what is integral of 1? It does not make any sense. Or I can write it like this also, epsilon to square also, epsilon square also, I mean. So we can write it like this also, that plus ln x square divided by 2 dx square. Now this is not defined, because we all know that a single integral can integrate only one time, right? So how we can say that we can go from here to here without creating any problem? Of course, there are multiple things which we have gone through in the process. So this integral is an invalid integral, and the process behind this has many things which I don't agree, right? Because I've told the points, okay, whatever points I had to say. So now these are just my opinions. So if you don't agree to this, then please let me in the comment section and tell me that where am I wrong, okay? And for me, this integral does not make any sense, and it is an invalid integral for 3 reasons which I have told. The first claim was that why assuming this dx as h and this dx as dx itself? First claim. The second claim, how can you go from a curve which has no graph to a curve which has a graph? Second claim. The third claim, if you are using this expression, okay, then how you can say that this will be valid for x to the power dx, because over here we will have an integral 1, and if I extend it more, it does not make sense either. right? And if another claim I have to make that dx is a symbol to use in integral, then I can say x to the power apple dx should also make sense, but it does not make any sense because it's dimensionally not valid, right? Okay, that is what I want to say. And yeah, that is what I want to say over here. So if you agree to my points, then please to like, and if you don't agree, then comment and tell where am I wrong. So these are just my opinions. Let me know in the comment section.